Okay, I am here to record a point. Point is that we are talking about the access modifiers in the C sharp. So there are basically five or six access modifiers. First is public, second is uh, private, third is protected, fourth is internal, fifth is protected internal, and sixth is private protected, and seventh is file. So except file, we are talking about all of the remainings. And this example helps us to understand different weird combinations and how those affects. So first of all, you can see that there's a class T1. It's a public class. And it has public, internal, and private members. Also, it has a nested type defined. The one M1 is public one and M2 is the private one. And both of these nested classes have different accessible members like public, internal, private, public, internal, private. So you see that there is a weird combination like uh, private, the container itself is a private, but the contained one is the public. So something like this combination is literally a weird one. But the compiler does not issue any warning or any error for these combinations, but actually this this combination work in a different way. So let me tell you in a brief. So this one T1, this is a top level class. Top level means just inside the namespace. So that's why we are calling it top level. Any top level entity means it is just immediate or behind under to the namespace, right? So top level elements have only two types of access modifier for those. First is public or second is internal, right? And that's why it is a top class. So that means it has a public. That means within that namespace or outside of that namespace, it can be accessed. But if I talk about the this class, this is also public. That means it also can be accessed from anywhere outside of this class or outside of the namespace of this class even. And if I talk about this M2, then it is private. Private means simply just look its parent. Who is the parent of this private member? So the parent means container one. The container one is T1 is a container for M2 class. So that means this one is accessible only to the T1 because there is a relationship between T1 and M2, which is kind of a parent and child relationship. That's why a private means it is accessible to its immediate parent only, which is T1. Parent means container one. Fine. So it can be accessed within the boundary of this T1 definition. That is why if you see here M2 dot public int, M2 dot internal int, which are accessible here. But if you say that M2 dot private int, then M2 dot private int is not accessible because M2 dot private int is private. This one is a private member to its parent means M2. That's why outside of the definition of this M2 class, we cannot access this private int. So that's why if I say that uh, M2 dot private int, it cannot be accessed, although it is not written here, but I generally say that it cannot be accessed here. Similar way, the M1's private int, it is a private one. Private but means it is accessible only to this container means M1, not outside of the container. That means here also it is failing. So you have to understand like yes, the combination of such things like private and public, these combinations exist and do compile, but how they behave is something different. So the things are basically based on the on which entity have which modifier. So if the class has public, that means the class is accessible to public. If class is private, means class is accessible to only its parent. If the member of that private class is public, that means that particular member is accessible to the uh, outside classes. But the class itself is not accessible. So these things are kind of weird, and definitely, if it is a private class, definitely is constructor. If it has a constructor, then definitely that we cannot create the instance of this class outside of this T2, T1, but we can have a property accessed if it is a static one. I mean, if it is not on instance, then only we can access, because if it is instance, then we can need a reference, and to have a reference we need a constructor, and that constructor should be public. But as we said that it is a private one, and private class I think cannot have a public constructor. So I think that yes, let me to try if I can try, like if I can make something like that. I just need wait, let me to try. I think you're putting a good question for me, but let me to try check that if it is possible. I'm trying. I mean, I don't know whether you can see my Ubuntu screen or not, but what I'm trying is that I'm just opening an Ubuntu. I'm writing this code, or let me to write this code somewhere else on web. Okay, let me to write this code here, and let's see how it works here. Run. Okay. Uh, okay. What I need to do is that I need to actually make the instance of M2. So I am willing that I can have a public M2. Fine. And let me to compile it first. If I can compile it. Okay. Uh, if I can compile it, so M2, where is M2? M2 is here. Let's say if I put any non-static, I mean, if I can put any non-static property here, and let me to create the instance of M2. Let me to run it first. Okay. Let me to M2 equal to new M2 M2 dot, sorry, M2 dot public int 1. Let me to see what happens. Okay, so okay, T1. I think I need to print this console dot write line error. Okay, error unexpected. What is okay? Oh, yeah. Oh, system dot console. Okay, system dot console. 90. Press any key to exit. Exit. Oh, wait a minute. Wait a minute. I mean, this combination is also compilable. Like private class can have a public constructor, and it can also have a public instance. Field, and that can be accessed within this one. Okay, obviously this is a private class, so it cannot be accessed outside of T1, but it is accessible outside of T1. It is not accessible outside of T1, but within the T1 itself it can be accessed. But the thing is that we can create the constructor, you can access the constructor. Okay, fine, fine. So ultimately saying, if this class can be accessed within the T1, that's why we are able to access its constructor. That's why we are able to access its public int one. If I do the same thing outside of this, then I think I can't do it. I think I can't do it. Same thing. T1 dot this and okay. I think this will not work because M2 is not accessible outside of T1. So this constructor will not work. T is inaccessible. Yeah, correct, 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 correct. Fine, I got it. So ultimately saying the combination do compile, such weird combination do compile, but the things will not work if we do not understand the behavior. So the combination, we need to understand the behavior first, like how this combination will work, and then we can use it. Yeah, that's fine then.